Everyone, in this video we're going to be doing the reverse of what you've done so far in your notes. We are going to be taking a graph and getting the absolute value function from it. And so it's fairly straightforward when we're talking about a linear absolute value function. All you really need to do is find the slope, and you know right away that the slope can be is your a value. The one note I'll say is when you're finding the slope is make sure you take 2 points from either the left side or from the right side. Do not mix and match between the two sides, otherwise the slope is not going to be useful. That won't mean anything. Like you'll get the slope of the secant line, but not the actual line itself. Once you've gotten that, you just need to know where your vertex is and plug the vertex directly in for P and Q. For these questions, you have to be either given the vertex in terms of like the graph or explicitly told where it is in order to figure out what the absolute value function is. You can't just be given a piece of a graph and be told that it's an absolute value function without more information as to where the vertex is occurring. And what I just said out loud is essentially what this is saying here. So right away I'm going to find the slope, and I can see, hey, there's some lovely points given. You can use any two and you'll get the same number. So I'm going to use the two polygons. So I'm going to say, all right, my slope is going to be 7 minus 5 all over 2 minus 0, or 2 over 2, or 1. Does that make sense in this context here? Up from 5 and over 2, and then I'm also going over 2. Yep, makes sense. So y is equal to my a value. I'm just going to not bother writing it because it's 1. You can write a 1 if you want. So absolute value of x, in this case, is going to be minus 2. Close my bracket, and then plus my q, which is 7. So just plus 7. Now I have to be cognizant of the fact here that I'm always going to get a slope, and it's either, in this case, the left side's positive, the right side's negative. But in order to figure out what the sign of the actual function is, I've got to think about, okay, is it opening upwards or downwards? Has it been reflected or not? And clearly, since this one is opening downwards, I want to have a negative in front of my absolute value sign to communicate that this function opens downwards. And that's it. It's really that simple. Find the slope, plug the vertex in, and then reflect for 2 seconds on the sign to see whether or not it should be positive or negative as a leading. So let's look at this one right here. So again, I'm going to quickly find my slope. So my slope is going to be -6 minus a -4 all over -5 minus a -7. So -6 minus -4 is going to give me -2 all over -5 minus -7 will also give me 2, unless I'm crazy. Yep, so it's a -1. So y is equal to, now you can probably already tell that this is going to be a negative. It's opening downwards, so it's going to be negative leading. I'm not going to even think about that though right away. I'm just going to say, okay, it's a 1 that I write here. I don't have to bother writing it though because it's just a coefficient. So I'm still just going to do x minus a -7 onto plus a -4. And then we would clean this up a little bit. And again, I'm kind of showing all the steps here. You don't have to show these interim steps. And by the way, like I said, I would take the 2 seconds and think about, okay, it's opening downward, so I do want that negative there. So then I would simplify to y is equal to negative onto x plus 7, close the absolute value sign, and then a -4. And that would be the answer that is the most cleaned up, the most simplified. Let's see if we've got another one. Oh, and that's it. So if you've got any questions, come find me in class. If not, I will see you guys in the next video.